Good evening, everyone, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments, where tonight our panelists are going to help you get the most out of your TI-84 graphing calculator. My name is Mike Houston, and I'm the moderator for this event. I teach Algebra and Calculus near Pittsburgh, where I use TI technology to make tough to teach, tough to learn concepts accessible to all my students. And tonight we're really lucky to be joined by our two experts, Linda Griffith and Ann Schlemper. Linda retired in 2018 after 38 years as a mathematics educator. She received her bachelor's and master's from the University of Central Arkansas and her PhD from the University of Texas. She was a professor of mathematics at the University of Central Arkansas and completed her career as a mathematics consultant for the Wilbur Mills Education Service Cooperative. She's a former president of the Arkansas Council of Teachers of Mathematics and the Arkansas Association of Mathematics Leaders. She served as both an elected and appointed member of the NCSM Board of Directors. She was a fellow of the Kellogg National Leadership Program and also serves as a national instructor for T-Cubed. Linda, it's great to have you with us tonight.
It's great to be back with my T-Cube family.
Absolutely. And Ann is certified to teach grades 6 through 12 as a PhD in mathematics education. She was a 6 through 12 public school teacher for about 6 years, a teacher's assistant at the University of Missouri for 6 years, and now she has been at Columbia College in Columbia, Missouri, teaching math and math education for the last 21 years. Ann has been a T-Cubed regional instructor for about 18 years, and currently Ann's interests lie in the area of STEM and STEAM, although her love will always be fractions. She has 2 children. Her daughter Kaylee, named after the mathematician Sir Arthur Cayley, is an artist, and her son Isaac, named after Sir Isaac Newton, is a college student studying chemical engineering. So Ann, it's great to have you with us as well.
It's great to be here. I'm excited, and I hope that we have a great time together.
At this point, Ann is going to discuss our agenda.
So we've already done the welcome and introduction, so welcome. And we're going to do some middle school topics. We're going to be doing some fractions and proportions, and we're going to see how maybe some of the things we learn when we're doing fractions, proportions will carry through the whole time. And then we're going to look at polynomial and rational functions, which obviously is in algebra, pre-algebra, algebra 2, and on. Then we'll look at extrema and limits. So we're going into a little bit of precalculus and calculus topics. And then we're going to come back around and look at some geometry topics, including area, perimeter, slope, and distance.
Awesome. And thanks so much. Sorry, Linda is going to discuss our expected outcomes.
So we hope the following things happen for you tonight. We hope you feel like you can use TI technology to work with fractions. We hope you can use TI's technology to do proportional reasoning with ratios and rates and solve real world and mathematical problems. We hope you'll be able to use our technology to explore polynomial functions and rational functions. I think you'll find it a useful tool in exploring extrema and the concept of limits. And finally, that you'll be able to use the technology to explore geometric concepts such as area, perimeter, slope, and distance. And this is a very ambitious agenda and a very ambitious set of outcomes. So I know we're going to try to do some things where you guys can follow along tonight. But if you get a little bit frustrated, don't worry, because this webinar and the associated slides will be made available on the TI website. And I believe that you're going to get an email with a link to those when they're available.
Absolutely. Thanks so much, Linda. As a reminder, the session is being recorded, and we'll provide a link to the event certificate of attendance at the end of the webinar, as well as a link for the documents at the end of the webinar. Tonight, we'll be using the chat window to send general messages, and feel free to ask any questions of Linda or Ann using the Q&A window on the right side of your screen. With that being said, Ann, let me pass you control, and you can share your screen.
Not the one with all my little desktop icons that you were making fun of earlier, right? Okay,
Not that one.
Not that one. Okay, so we're doing getting the most of your TI-84, as you know, and so we're going to start with our middle grades topic. So first of all, I'd like to be able to show you the cool things that you can do with fractions. So what I'd like to do first is kind of show you the old school way of doing fractions and then the cool way now. So let me get to the calculator. Try that again. Okay. So when we used to enter fractions on the calculator, we would do something like 12 divided.
And we're not seeing the calculator screen.
You're not?
Yet.
Okay, we'll try it again. Now are you?
No, ma'am.
Oh, this is going to be frustrating. Okay, I'm getting really not happy with this. Can you see it yet?
Nope. And
No.
maybe we could just do the backup plan that was working during the dry
Okay.
run last week.
Okay. Oh, wait, here. Can you see it now?
There we go.
All right, sorry.
Success.
Okay. Success. Okay, so the old school way, you know, slanty fractions, which I call ugly fractions because it causes so much trouble later on in algebra, we get something like this. And then I guess, you know, if you look back at your old menu here, you could change to a decimal if you wanted to. But with the new menu, we already had it a decimal. Keep me on my toes here. We could change it to a fraction, and notice it goes up and down here. And but with the alpha menus, we're going to be looking at several of these tonight. So alpha in green, and you see F1, F2, F3, F4, and F5. So the one that, you know, I already mentioned that I love fractions, but alpha F1 is amazing. So this is the pretty fractions, and you hit enter, and you can do 12. And then arrow down and do your 36. And if you have a little bit like me, I like to go to the right, but you don't have to. You can just hit enter right now. I just like it to look pretty before I hit enter. And you notice that it already simplifies the fraction. Now, if you had a mixed fraction that you wanted to enter, then you could hit this again. And you can see that you have a mixed fraction, and you can convert between mixed and improper. So let's enter a mixed fraction. I'm just going to enter anything, and you may do the same at 1. And let's do something that simplifies, 6/10. And so if you enter here, you see that it became improper. But if you then do alpha F1, you can change it to mixed again.
Some of you guys that were fans of the old 73, it had some of these
Mhm.
features. This really brings this 84. It's a really neat feature.
And one of the things we're going to talk about is, like, if it doesn't simplify, then of course it just won't. I'm just going to do a simple one. We'll do 25/27. I think that's what I had in the slide. And so it won't simplify. So, I mean, I know on the 73 you could turn off that ability to simplify, but this, it just does it. So then the other thing, we all know that students don't particularly like converting, repeating, or they don't sometimes understand repeating fractions. And what's really cool here is if you put enough 4s, which I'll let Linda talk about that, you can do alpha F1 and it'll change it to a fraction if you hit 4. And you can see that it's 4/9.
So one of the connections I'd like to make is to some of the things we do in middle school or even in fifth grade, 4th or 5th grade, are trying to lead kids to the understand of this ideal of a limit, getting close to. So one of the activities that my students did that they really seemed to get a lot of was they would take 4/10 and convert it to a fraction and get 2/5, and 44/100 and convert it to a fraction and get what we're going to get here, 22 and 11/25. And then we would just keep adding 4s. It was kind of like a repeating activity. Well, what happens eventually is because of the tolerance of the calculator, when it gets past so many decimal places, it decides, okay, you're close enough to what this repeating fraction would be to actually give you that repeating fraction. So as a true fraction. So I don't know how many 4s you have to put, but we certainly could explore that. And there it is. So evidently this tolerance was 1, 2, 3, 4, 5, 6.
It didn't write 4/9.
It didn't write. No, it hasn't done that yet, has it? We didn't do that. Hold on. I was expecting it. Oh, you're doing fraction. We need to do decimal to fraction.
It shouldn't matter, right? If you have it as a fraction, then it'll change it to a decimal.
Yeah.
I don't know. I
What's
don't
up
know. It did
I
it
don't know.
before. It did it
Put about
before,
four
like
fours and see what
right
happens.
here, it did it.
Yeah.
We have proof that it can do it.
We have to prove it. We just have to put enough fours anyway. But that was a really cool discussion in class with kids about really, you know, because they all think that decimal 33 or 33 hundredths is 1/3. And this, I was trying to convince them that it's really not, it's 33 hundredths. And so this was a pretty nice discussion to have in the classroom with kids.
And then just something, you know, a little quick hint is like, if you are operating with them, it's kind of cool. Oops, sorry, that's not what I had on there. If you wanted to like subtract them or quickly change it to addition, you can just go up on top of that and change it to addition. And so then you don't have to keep entering things, but you can do this with any operation. And just keep going up there and change it to what you want it to be, or change the fractions themselves, right? So it's a pretty quick change. Like if I don't want to add 1/2 and 1/3, I wanted to add 1/2 and, I don't know, 2/3 or 1/4, we'll do that. Then we can do that, and you can just copy and paste and bring that down. Okay, so I'm going to try this again. Oh, tab. Are we on? Do you see it now?
The PowerPoint, yes.
Good. Yay.
Right. Yay.
Success. Okay. So now we're going to talk about proportions.
So one of the things that's always bugged me is that the method that we've taught kids to set up these proportions, we call them proportions, and then we said just it's magically, some people say cross multiply, some people say the product of the means is equal to the product of the extremes, but it just seems like magic. And so I began to ask myself a long time ago, is there a way to get kids to really understand what this reasoning is about? And actually, a proportion is one of the first functions that students encounter. And it's a function in which the ordered pairs x, y, the ratio of x to y is always the same. So a better way to look at that, and less magical, is ratio tables. So Anne, take us through some of those.
Okay, so this is a ratio table, and I have some more on the next page, but you know, like if you start with this, you could divide by 2, then multiply by 3, you know, just to get, and middle school kids and even elementary school kids can do this, upper elementary. And it really helps them understand that a ratio is a comparison of two numbers, and that no matter what, those ratios stay the same. And it's kind of different than fractions as well, because you can add them without getting a common denominator. So it's an interesting procedure. So I created a cell sheet inside of this. And so cell sheet's been on the 84 for a long time, but now this cell sheet app is so much, I think, easier to use, and it's very much like Excel or any other spreadsheet. And so you can see here that they've got these soft keys, and so the menu lines up with graph, and you can see that you can save files. So we can open up the file that I had, and this is the ratio table that I created, and you can see that I entered a formula here. So just like in Excel, you can take whatever this was and divide by 2, or divide by 2, and the kids can do this, divide by 2, divide by 2. And I filled the formulas over just like you do in Excel. And we're going to do one of these later, but then I just added those cells. And so I just find it so much easier than the previous cell sheet app, if any of you have tried that out in the past. So, and you know, they could do anything they wanted to this original ratio or the ones above. So do you want to add anything, Linda?
Yeah, well, I think this is such a powerful tool to start teaching kids about ordered pairs and the way they work and the way relationship between numbers works, and about what a function really is. I was doing an activity in 6th grade classroom, and I wasn't using the word function. I was just talking about proportional relationship. And one of the students says, what do you call this kind of relationship? And I don't care if it's in the curriculum or not. When you introduce something as important as function to sixth graders, you need to give them a name to call it. So this is such a powerful tool with early grade students to lay the foundation for something that's going to be the basis of the rest of mathematics.
Okay, and so now we're going to move on to some algebra topics, polynomial and rational functions. And so I've already entered this into my Y1. So if you guys want to enter that into your Y1 while I attempt to pull it back up again. Woohoo! I feel so great. You can see it, right? I hope. So I'm going to get out of here. And I'm going to go to my Y equals. And you'll see I have many things in here, including some plots I don't want. Let's turn those off.
See how she's turning things off. And this is a great,
it's okay if you, yeah, go ahead. Sorry.
It's a great tool for teachers to get all the problems they want to talk about in before class and then be able to turn them on and off as they explore with them.
And we're going to explore this when we get to the rational function. So if you don't see this on your Y equals and you don't see this, it's okay. We'll take care of that in a minute. So for now, just make sure you have Y1 entered. And we're going to take a look at the graph. And I'm going to hit zoom 6. I try to do that with my students so that we're all looking at the same thing, or whatever window you want. And so here's our polynomial. Well, that's not good. So there's lots of ways you can do this. You can zoom in or out under zoom, or you can change the window. So let's take a look at just changing the window. And we can just kind of, I know what it fits. So I'm going to try -60. And 60, and we'll see if I'm going to leave the x's the same. You could change them if you wanted to. And now we see all the important features of the graph.
So, Anne, one important tool that I've found to use with kids is actually have them do some simple things between if we're setting the x between -10 and 10, to just pick some easy numbers and plug them into the function to kind of see what the y's are looking like, so we have an idea. I think it's so important that we don't just use magic all the time, that we discuss with kids, why is this window working better for us?
Okay, so since you brought that up, let's go to plugging things into the function. So
exactly.
Another part of, we're going to look at all these later, but so you can see what's under F2, you can see what's under F3, but let's jump to F4. To get Y1 and all this stuff before, you used to have to go vars, Y vars, function, and then pick it. And they're like, ugh, that's such a pain. But now you got a shortcut to these. And so you can just jump to them and you can put your parentheses and you could do Y1 of, I don't know, 5 and see what it is. And what's nice again is you can just copy that and then just put in new numbers. And if you have to, you don't really have to close the parentheses, but I'm sure all of you are pretty much like me and you must close it or you feel, so you can see, plugging different values in here can help them set the window. Thank you for that. That was nice. Unplanned, but nice because we need it later. I'm okay. I can do this. We're teachers. We're flexible.
You're doing great.
So if we trace, which you might want to do first with kids, you see all these kind of gross decimals and stuff. And so you can change what you're tracing by. But another thing to do would be to maybe teach them how to find these mins and max. And you've probably done it before with the old calculators or the black and white ones. What's nice with the color ones is that when you do second trace and you want to find the maximum per se, you can go to the left. And what's nice now is like on the black and white one, they just put that triangle, but now they've got this blue line, and it's kind of like that limiting process again that you were talking about, right? As we move into this little neighborhood between here and here, is this a maximum, a relative maximum. And so then you can find the maxes and the mins that way. If you wanted to find the zeros, you could do the same thing. You could trace to them if you wanted to. I didn't hit trace. And you could kind of guess where they are. Or you can, again, do the second calc and 0. And again, you want to go to the left of where you think it is and to the right of where you think it is. And you can see that it puts that range, and then you want to give it a guess. And so then it'll tell you that's 0.
And those lines, they're a little thing, but they're one more thing that helps us deal with this conceptually.
So Linda's jumped ahead on, doing things on the home screen, but let's talk about, like, if we wanted to talk about the end behavior as x gets really large or as x gets really small, we could see what was happening. And I think I went for x gets really large. So let's get out of here, go back to the home screen. And since I already have the y1 in there, I'm just going to put large numbers in here and see what happens. And then we could just keep putting large numbers in here. And so we can see that it approaches negative infinity.
And I love the way this gives you a great opportunity to talk about scientific notation and kids. I think it's important that they see numerically what's happening. It's graphically is very important, but some kids tying the numbers to the graph is a little bit more difficult, and this tool really helps us do that.
And just to remind people that you can also do this in a table. It doesn't really matter where you start your table at, this is probably what yours says. But you can put the independent at ask and then go to your table and put in the values that you want. So this is just a little bit another way of doing it. I've used both with my students, and half of them like the table and half of them like the home screen. So it doesn't really matter to me which way you want to do it. Now, it's hard to see these, but if you go over on top of them on the Y, you can see what those are. So that's I think the only detriment to using the table is sometimes they don't know, like sometimes it'll round to a whole number when we don't want it to round to a whole number, and we'll see that here and later on in some more slides. So one of the things I do in my college algebra class is we write programs. We write a lot of programs, and I do it in some other of my classes too. But in particular, this is a very simple program, and we thought we should do the quadratic formula. I would sing it to you. Maybe I'll sing it to you while we're programming. But this is just a really short program, and it is in the slides. And so if you can't keep up, or you get behind or get frustrated, don't worry, because it is in here. So this is what we're going to do. And we're going to see what you need to do to run this program to get imaginary solutions and so forth. So we're going to get out of here, and we're going to go to program. And so there's 3 things at the top: execute, edit, and new. And so that runs the program. You can edit a program because it automatically saves while you're doing it. And then we're going to do a new one. And I probably already have quad form on here, so I'm just going to call it QF to speed things up. And so to get to the alphabet, it's already locked. It's blinking. So you just look at these green letters above your keys, and you can do QF is what I'm going to call mine, and then hit enter. And so now we have a program, and each line of your program needs to start with a colon. And so here's the name of your program. Here is the first line. I was a minor in computer science in the late 80s, but my teacher said I wasn't very good at being friendly. So this is not necessarily friendly. You need to know that A, B, and C are, what they are in order to run this program, because that's what makes it kind of simple. So what we want to do is now that we're in program and we hit program, you'll pull it up and you'll see, if you're a programmer, all these loops and things. And then we have IO, which is input output. And there's other things over here that we don't need unless you're going to be using the TI Innovator. So let's go down. We want them to input, or you can prompt. We're going to prompt them for A, B, and C. So we're going to hit prompt, and then we're going to hit alpha A, and then the comma button is its own button. It's right above 7. It's a black button. And then we're going to hit alpha B, comma, alpha C. So then they'll have to enter those values. Now I'm going to hit enter to get a new line. Now, what I like about making them do this program is it really makes them understand the quadratic formula and the parts, because you have to make sure you do it in the right order and order of operations. So let's do parentheses and then negative b. Let's do the plus part first. Then the second square root. Oh, you asked a question the other day when we were doing this. Remember, Linda? You said, can we do pretty fractions in here? And you can't.
Yes.
You can't.
Not yet. It seems like with TI, every time I suggest that something might be neat, it happens sooner or later.
Yeah. So they need to know that this parentheses is everything in the square root, and then we close the parentheses for the numerator. So that's very important. If they don't type it in like this, it's not going to work. And I kind of like it when someone messes up so I can make that point again in class. So I always say when someone messes up, oh, I paid him to do that. Okay, so then we 2 alpha A. And what's cool now with this new operating system is we used to have to do this whole thing again, but we can use the alpha F5 menu and we can copy this line, which is nice. And then we can paste it below. And now we don't have to type all that again. I was so excited when I saw this. If any of you guys are programmers on here, I was like, oh, look at the shortcuts. I'm so excited. Okay, and then, so, oh, we need to store these. I messed that up. So we need to store these values in something. I looked on the thing, I stored it in M and N. So this calculation is going to get stored, which is STO down here. And I just chose M and N because I don't like to use X and Y in programming because of, you know, the fact that they are ordered pair. Okay, now we just need to display M and N and the program's done. So this is a very short program. So we go back to program, we go back to input output, we go to display, and we need to display our M and an N. M, comma, alpha, N. Now you used to have to get out of here, but to run execute it, but now again, it even tells you up here under the alpha F5 menu, we can just execute it from here, which is nice. So now it's going to ask me for A. So I'm just going to do one that hopefully we can all factor tonight, 0 and -4. Okay, I think I used a minus sign just to show you that you can't do that.
Good topic.
I always tell my students not to do that. Now, what's nice is the program's still running if you don't do anything else. So you can just hit enter again and you could do another one. And I'm going to do +4. And if you guys get an error like this, that means we need to fix something. And so we go to our mode and we need to change it to A plus BI mode because it was in real mode. So that's a good conversation to have too, right? When do you get imaginary? When there's a negative under the square root. So now if we quit this and do it again, 1, 0. Okay, what did I do? Okay. Enter. 1, 0, 4.
I don't know what happened there. Isn't it nice that you see those imaginary solutions like that? That's so nice.
And so then I decided to do one that in the note slides that you see, I decided to do one that was irrational just for them to see that there are limitations to technology. I mean, obviously we're promoting technology here tonight, but we want them to know that technology can't do everything for you. So they can then check their answer if they've done it by hand and know that the square root of 5 is that number. So I kind of like that it's imperfect.
I think that helps them to understand that those radical 5 is still a point on the number line.
Yeah. Okay, so now we're going to jump to rational functions. So we get to see why it's important to have this app on. So I'm purposely going to quit the app so it's not there, and I'll show you how to put it back. Oops. I leave it on all the time, and I'll show you why. So quit inequality graphing. is what it says. And so I'm going to go to the apps and you'll see inequals. I usually don't like it when things are spelled badly, but you'd only have 8 letters to name something. So we hit enter and you press any key and now it's back. So what's cool is I'm going to turn off this function. I'm going to turn on this one here. So this is the one we're going to be looking at. So we're going to be looking at their asymptotes. So you notice that I've already plotted y equals 5 and I wanted it to be green. So I just went over to the side here, green for yes, you may cross this asymptote, right? And you can hit enter and you can change it to any color you want. You just kind of slide through there, but I like green and so I'm sticking with it. And then you can say, okay, and you can change the style and everything as well. But then this is what's cool. Like we've all been dying for vertical lines and now we can do it. And some of you might have used, I used the inequality app a long time ago for, you know, solving linear programming problems. It's awesome for that. But here we want to put in our asymptotes. And so I want them to be red. So we should have 2 as an asymptote and -3 as a vertical asymptote. And I'm going to go color this one red. And so I'm going to go ahead and hit zoom 6 again so that we're all in the same window, but you could have any window that you wanted. And if you wanted to see that, you know, they sometimes don't understand the horizontal asymptote. So again, if you wanted to zoom out or change the window, however you wanted to do it so that we go out further, I'm just going to exaggerate a lot. And you can see that the ends of the graph start approaching that. That doesn't look very good, but you get the idea.
Yeah.
I probably should have changed my step. Let's do that.
Scale.
That looks a little better. Okay.
I think that's a really nice example. I think this is an example where the color really helps you. You know, I was so thrilled when you could do something like this with a graphing calculator, but now the color and the inequals app make it even better.
Yeah, I like that. And so now we're going to be looking at extrema and limits. So I wanted to show you some other zooming windows because I thought it'd be nice because a lot of us do have to teach trig or calculus. And so I really love the zoom for this. So y equals, we're going to turn off our x equals as well. So to turn them off, you just hit the equal sign. It's like a toggle button and we don't want that to graph. And then we're going to go back to the y equals and we're going to turn off this guy and this guy. We're going to turn on Y4. I mean, you could just be retyping them if you wanted to. So I'm going to zoom 6 just to show you what it looks like. But if we actually hit zoom trig, which is amazing, trig teachers, you're just going to love this because it's just beautiful. It's a beautiful window and it's beautiful for tracing. So you can see that it's tracing in some nice numbers. And so you can see different things that are going on here is it actually lands on that value of pi over 2. And so again, yeah, you can find these extrema, but just using that window is helpful, right? Because I don't really need to do the min and max anymore. This is so much faster when you're doing trig functions because now you can see that this min here should have been.
It was
3 pi over 2.
Yeah.
Yeah. Oh, yeah. So, and so then you can just see where the zeros are too. So that's just so nice. I just love this window.
I do too. And it's, I mean, I remember I was so excited about getting graphing calculator, but I remember working really, really hard to try to figure out how to set a window so it would turn out nice. And now it's so easy. Of course, I've been around a long time.
Okay. So if you do teach calculus, we talk about the fact that it's decreasing here. So the slope of the tangent line is negative. And it's increasing here, so the slope of the tangent line is positive, but the slope of the tangent line here should be 0. So I don't know how much you looked at the F2 menu. Some of my calc students didn't know this stuff was here, and they're like, man, look at this. We got summation, we got derivative, we have integral. Okay, now, but it's actually numerical only, unless you have a CAS computer, which a TI Inspire is. But if we wanted to do the numerical derivative, and you can actually take the derivative with whatever respect. So those of you who did not like Leibniz notation, I'm sorry, it's pretty cool. And so alpha fy1, and so you can just do that, and you can take the derivative of wherever you want. And I had it at negative pi over 2. I will use negative this time instead of minus. Will not make that mistake again. And you can see that oh, I did y1. See? Weird.
Yeah.
Y4.
Yeah. Now look how she didn't have to retype that whole thing. She just copied what she had.
Yeah, if I can get to where I want to.
That's wrong. Or that isn't what we intended to do.
Okay, that's what I intended to do.
Yes. And I think, at least in the pre-cal classes that I've taught here in Arkansas, we don't teach any of the like chain rule, product rule, any of those rules for calculus, taking the derivative, but we do teach the ideal of changing y over changing x and let that ideal of moving we teach the secant line with slope and then letting the secant line get closer and closer to the tangent line. And I think this power for them to check so in pre-cal, they're making an hypothesis. As I come in toward negative pi over 2, my y values are getting closer and closer to 0. And this lets them verify that ideal. So I think that's really getting close. Yeah, the slope's getting closer and closer to 0. So I think that's an important ideal.
Okay, so now since we are talking about trigs and limits, we're going to turn this one off and turn this one on. So we're going to be looking at the limit as this thing goes to 0. So let's take a look at it, because that's normally when we have to like wave our hands out until we teach L'Hopital's rule, right? So we teach L'Hopital's rule. It's sometimes hard to tell people what's going on here. And of course, we can trace, and we can see that when you trace it, it usually puts you at the y-intercept, and you see that it's not defined because you can't divide by 0. But you can go to either side, and you can see that it looks like it's approaching 1 from the left, and it looks like it's approaching 1 from the right. But yeah, go ahead.
Can I just say that because that 0 is in the very center of your window, that's why you're going to hit it exactly. So if your limit is happening at something other than, if it's happening at something other than 0, you might not hit it exactly. But I love the way when you hit 0 exactly, it doesn't put error there. It puts nothing under the y equals.
So we're going to look at the table as well. And I had it set for, I'm going to put it back to auto. And I'm going to go look at the table. And you can see on the table that it says error. But what's really nice is you can see press plus for delta table. You don't have to go back to the table set. You can just hit plus, and we could change this to 0.1. You want to talk about the math here?
Yes. So you're starting to get to that epsilon delta ideal. So we're incrementing our x's in 1/10, and we can now see that at negative 1/10, we're at 0.9938, and at positive 1/10, so we're really close to 1 there. Now, if you want to go back and do your little trick again, where you do your plus for your delta table and change it to 1/100.
Let me show you this mistake I made. When you do the plus, whatever you want in the center, make sure that's what you're on before you hit the plus, because you saw me scrolling to get to this. So yes. Now I'll hit the plus, and we'll change it. What do you want me to go to?
1/100.
Oops, how many decimals do I need?
Not just 1. Okay. And oh, look, now what? Now, but this is a neat feature. Now you say, well, that is 1. Well, go over and now look, it's not 1. I love this feature. Even though to display it in the display, it rounds it to 1. When you get on top of it and look down in the entry in the bottom there, you can see that it's not 1, but it's getting closer and closer to 1. So this ideal of I can change my delta table, I can change that, and then it changes how close I'm getting. So the closer and closer I get to 0, the closer and closer my functional value gets to 1. Although it will never hit 1, it will be close. So it's close enough it doesn't matter. Or it matters, but we get the idea.
I love going to T-Cubed conferences. It's been sad with the COVID, but you know, these virtual things are helpful, and I learn something every time. So Linda taught me this. We're going to do the ordered pair thing. I was so excited.
Okay, so I always call it the wrong thing, but I want to open a bracket. Is that what it is?
Bracing.
Or brace. Yeah, brace.
It's
Okay.
like it's on your teeth. So above the parentheses, there's braces.
There's
Brackets are the harder ones.
So you can enter an ordered pair in here. So we're going to enter 1/2, 0.5.
Do you want to do 0.5 instead? I did negative 0.5 on the
negative 0.5. And then comma. And then we have to do y, which one is this?
5.
y5 of negative 0.5.
And so you use the parentheses there.
Mm-hmm. And then close the parentheses and close the brace. And then when you press enter, it gives you a decimal approximation of the functional value.
At the particular x.
Now you got to be careful right here. You before you do anything else. Now we're gonna get this thing to behave. We're gonna be able to just type in one more time and press enter and see a lot of stuff. So she's gonna pull that down. Well, so in where you have the negative 0.5, you want to put negative. You want to put A and S.
Oops, I lost my. I'll put it back. So A and S is above the negative sign in blue. So
which is and then parentheses 1, close parentheses. So that's the first element of the ordered pair above, right? Plus.
Oops.
And then how do we want to increment? Let's increment in, I think we decided hundreds, didn't we? Or no, we decided 0.05.
Yeah.
5 hundredths. Okay, now put your comma. So what that's going to do is it's going to take your last part of your answer, the first part of your last answer, and increment by 5 100ths.
Oops.
Now you're going to do
Sorry.
now you're going to do A and S again, and 2 in parentheses.
We did answer 1 both times, didn't we?
Oh yeah, we do answer 1. No, we have to put the Y5 there in front of the answer 1.
I lost that. That's my fault. So alpha Y. That's what's going on. What's going on? Oh, I hit F5 instead of F4. I love it when I make mistakes.
Yes.
So now we want to put answer
1.
It's much quicker if you're not making mistakes. So
well, but it's worth it in the end when you see what happens. And then close your parentheses and then plus 0.5. Okay, so now close the parentheses, close the brace. Now.
Sorry it took me so long, people.
No, it's fine. Now press enter. And now we're at negative 45 100ths. But now all you have to do is just keep pressing enter, and it keeps incrementing it, and you get closer and closer to 0, and your values are getting closer and closer to 1, and it's so cool.
And then when you go too far, it says that
you can't divide by 0.
So the next thing would have been 0.
0, yeah. And if you don't believe that, then you can go in and increment by a smaller amount. And this is not with this particular problem, but this is how I always, I do it with a sequence rather than a function, but this is how I introduce the definition of a limit of a sequence by using that technique. Okay, so moving on to geometry.
Okay, so for geometry, these type of problems, you want to talk about these types of problems?
Now, these are classic problems in a middle school class. That's perimeter of a rectangle with a fixed area, and the next problem will be area of a rectangle with a fixed perimeter. And these are classic problems that we do in middle school. And I taught a class for years. It was calculus for middle school teachers. how are you going to teach middle school teachers calculus? Well, you start with something that they do in middle school, and then you show them this is how middle school kids do it, and then this is how it's going to be changed in high school, and this is how it's going to change when we get to calculus. So these are great problems. They're classic problems. Everybody's going to do them. And let's see how the calculator can really help us enhance this problem.
And I was going to have you guys do this, but I think for time, again, I'm using the cell sheet, and I love it. I love spreadsheets in general. I think it's an important skill to have. But again, I've already saved these, which I love. And so I'm going to open fixed area. So what we could do here, I actually didn't save this one. So I'll open the other one. Sorry. So we could do that one, or we could do fixed perimeter, which I did save this one. So it's a similar problem. You get your thing, and if this was calculus, you'd end up taking the derivative of this, or in algebra, you would graph it and find the min or the max, you know, just graphically. So, but what I did here, open the other one. Is I just picked a number, and then with the relationship that they had to add to 250, I just put that in that cell, and then I had it multiply those. So then once I had that set up, I could just fill this down just like in Excel, and you see that this formula just was really easy to fill it down. And so then they could put in any numbers they wanted into this spot. So I'll just come up and change this. So if I change this to 40, it's going to change the values. Or if I change this to 110, it's going to change the values.
Make that one 124.
Yes, ma'am. Just kidding.
And then the one down below it, make it 126. Look how much you can explore, because my kids say, how do you know 120? Well, we can now go up where that 124 is and make it 124 and a half. I mean, do y'all see I hope you can see the explorations that you can do here.
And then if they try to put in 250, you don't have an area, so that's fun. I just think it's fun. I mean, you could have this set up for the kids and share it with them just by linking it to them. But I think the process of making it is important too. And I learned to do it, and I'm old, just by Googling it. I said cell sheet app on the TI-84. So it's pretty easy. If you hit range, you can see you can cut and copy. So I thought it was pretty easy. So and again, I don't always feel good. So here are some other programs. My nephew, or actually he's my great nephew, goes to school in St. Louis, Missouri, and he came home for Christmas. He says, we're learning about slope, and it's just really old and tiresome, and I want to write a program to do this. And so he goes, we're just doing the same thing over and over again, which I thought was really ingenious of him, right? He knew you were just doing the change in Y over the change in X. So this is the program we wrote, and you could use any letters you want. Again, I don't like using X and Y, and so I just used A, B, C, and D. And so this would be one ordered pair, A, B, and this would be the other ordered pair, C, D. Clear home is a nice thing to put in your programs. I don't always put it in there because you see me clearing all the time. I like to have my screen clear when I do things. And then here's me trying to be nice, right? This is what my programming teachers, so this actually, if you want to display words, you do display and you put it in quotes. And then I also made sure that it displayed it as a fraction, the slope, because I think they need to see it as a fraction, so it'd be rise over run. And then he helped me. We just figured this, like, if we did this in general, so this is a good just programming skill, what would the y-intercept be? So we wrote out the equation and we figured out what the y-intercept would be. And so we wrote this program together, he and I, and so I just thought I'd run it for you.
And there's been some great discussion in the chat that I sort of missed. I'm a little, but I want to go, if we could just go back for just a second before we conclude about, there's been some really good conversation about the squeeze theorem when we were talking about some of those limiting things, and then some discussion about putting numbers in for the left and right bound instead of just tracing. And those are all
Yes.
wonderful ideas. I mean, the cool thing about a technology, any kind of TI thing is, even if you're presenting, you learn. It's like I wrote something the other day and I said, I've learned more from my students than anything else. Y'all have some great ideas over here in the chat, let me tell you.
About 5 years ago is when I learned that you could trace and jump to wherever you wanted to. So if I wanted to trace and I wanted to trace to pi over 4, I could put pi divided by 4 in here. That's what you're talking about, right?
Yeah.
And also when you're doing the max or the min, let's do max. Okay, min.
Can you type in the left bound and the right bound?
Yeah, that's what I'm going to do.
Yeah.
I kind of like to do, like, have them do it, but it also works to do this. So let's do a minimum, and we'll figure out this minimum down here. Oh, I was going to jump to it. So where do you think we should jump? Let's jump to 3. And then we could do a right bound at like 5 or 6, wherever you wanted to do. So we'll do 6. And then we can give it a guess. And it'll give it. So that's one of the things you wanted me to do, right?
Yes, I'm sorry. And like I said, I was so enthralled in working with these problems that I wasn't paying as much attention to the chat as I should have been paying. So I had some great ideas.
So I have quite a few programs, and if you end up with quite a few programs, you can just hit alpha and you will find the one you want with slope, and you can run the program. And so first you pull it up and it's there, and then we want to enter, I had the point 10, 6 and 6, 9. And it'll give you the slope and the y-intercept. Notice that this is really dark. So it is a slanty fraction, but it does come out, because the way I wrote the program was to make a fraction. So it's trying to make sure you know that. And then you could put in other things. But then
so Anne, we've got a question that I would like you to address. When they were enjoying all the programs like the inequality app and some of that stuff that you did, and they want to know if when they update their operating system, will all those apps show up, or will they have to do something else to get them?
The apps are there, but not the programs. So the programs are different. So apps are here. You should have most of these. Some of these I might have downloaded myself. But I think these are the ones that come on there. And you can get more.
Cell sheets.
You can get more. Yeah, you can download them from the website.
Yeah. The
TI website. But these programs, of course, are just written, but you can get programs offline pretty easy. Just Google programs and it'll come up. But I mean, you're just programming in BASIC, which was the first language I learned in like 1986 or something. But so here we're going to do that same thing, but I think I didn't pull up the right thing. Sorry. So you want to talk about this program, Linda? So we did slope.
Sure. Yeah, she's written the distance program, which is really cool, and I like the way she's shown the drawing over there on the side that really gets to the right triangle ideal of it. And guys, this is one of my big frustrations in teaching geometry, and is that we teach the Pythagorean theorem as one thing in one chapter. We teach the distance formula as something else in another chapter. We teach the equation of a circle as yet a third thing. And then we teach sine squared plus cosine squared equals 1 as a fourth thing. And they're all the same things, but I don't think my kids were ever understanding they were the same. So the Pythagorean theorem, you're given the side lengths, but in the distance formula, you're just calculating the side lengths and then using the Pythagorean theorem. And I think if you pay attention, I'm like Anne, I like the apps. Kids like the apps because they think, programs, excuse me, not apps. They think, I don't have to do all that work anymore. But really, when they showed me they could put the program in there, they showed me they understood the concept. So
yeah, that's what I said, is like writing these programs with the kids and letting them tell you what to do instead of giving it to them, I think is a great learning process. And I have some more programs for other things if anybody hits me up. I teach number theory, calculus, all kinds of things. So I have a great one that generates Pythagorean triples. It's pretty nice. So anyway, we're going to look at the distance one.
Okay.
And we're going to use the same numbers, 10. I wasn't very ingenious on my triangle lengths. So we will see that we have just a second, 3, 4, 5 triangle, because the distance between A and C is 4. The difference between B and D is 3. So we get the classic 3, 4, 5.
Yeah. So, Anne, one of the questions was, how does the Transform app work? And although we didn't demonstrate it tonight, there's a lot of really cool apps on there. Transform is one. I love Michael's answer that it's awesome. You can move graphs around based on perimeter. But the other thing we wanted to say tonight was that there's lots of stuff out there. For example, on this geometry thing, there's the Transform app, and there's also the Capri Junior app, which is a dynamic geometry program that you will
Kind
find.
of like Geometry Sketchpad or GeoGebra.
Exactly. And so we have only barely scratched the surface of the stuff tonight. And I know we're getting close on time, but our final 2 questions that we'd like to leave you with is, can you think of one thing you learned today that you think you might take back and use? And then a more important question to me is, what are some of the activities that we've explored that you would like to explore more on your own? And then, as Erica is saying in the chat, what have I seen go past my face that I want to know more about, like the Transform app? So I hope we've whetted your curiosity. So,
and if you, this is one of my favorite things to do with coding. You can do this on the 84 or this Inspire, and this is just on the TI website. And so it's got some great things, some great activities, and really kids can do this on their own. So like if there's some kid that needs something, he's ahead or something, you just give him his calculator, put him in front of a computer or an iPad, and he can teach himself, or she can teach herself how to program. And then they'll become better programmers and they'll teach you. That's what I like. So like I said, if you need anything, just feel free to contact us. There's our emails. And I think that's it.
Okay. Michael, did you have some closing words?
I need to stop sharing.
I sure do, as always.
Are you going to make me stop share, or I will? I got it. I got it.
All right.
All right. Thanks so much. So if you do have any last-minute questions, feel free to put those questions in the Q&A window. I know Anne and Linda will do their best to get those answered. I know we don't have a lot of time, but kudos to them for sharing their information, contact information, so you can get a hold of them after the webinar as well. To receive a certificate of attendance, go ahead and click the link in the chat window. Also listed as a link for the documents as well that Anne and Linda used tonight. And if these links aren't working for you for any reason tonight, just hang tight. You'll automatically get a follow-up email within a couple days. And that follow-up email contains links to the recording, the certificate, as well as the documents. And if you're watching this on demand, go ahead and copy that link into your favorite browser to receive your certificate.
Let me just say real quick that there's Python programming. Someone said they want to do more programming on the new TI, right? You can program on the Python.
Yeah, there's a new TI-84 model out that has Python included, and it's super exciting.
I am too.
So if you are in the need of any post-webinar follow-up, feel free to give us a call at 1-800-TI-CARES or send us an email, ti-cares@ti.com. We'd love to hear from you. When you leave the webinar tonight, a brief survey will automatically appear in your browser. Your feedback guides us as we plan future online events. So if there's things that I think I saw in the chat window that people are looking to see in the future, let us know. It really does help us plan for what we can do to help serve you better. So please feel free to complete that follow-up survey. Huge thank you to Anne and Linda for putting everything together for tonight. So big thanks to them.
We really enjoyed it.
Yeah, it was fun.
I agree. And a big thanks to everyone else for joining us tonight. Thanks for taking some time out of your summer. We hope to see you back online next week. Have a great night, everyone.